Hello everyone. Today I want us to continue with loops. So I want to mention just a few keywords that we normally use when we are dealing with loops. So the first one is very simple. It's called pass. And then the other one is continue. And let me just expound a little bit. Okay, the last one is break. So we're going to start with pass. So when do we pass? Especially when we are looping. So we're going to use a while loop. So let's say a equals to 0. We're going to say while true. So this will ensure that there is nothing to stop the loop. Equals to 1. So we are incrementing the a by 1 each time we iterate. And then I'm going to say if a is divisible by 2, if a is divisible by 2, that is how we write when a is divisible by 2. That means the remainder when you divide a by 2 is 0. Then we print a is divisible by 2. Let me just say while a is less than 10, so that we go up to 10. Less than 11. Okay. Okay, so and then I can say, as I decide here, else, and since I've not decided of anything, I can say pass. So that means when a is not divisible by 2, nothing will happen because I've passed. If I leave it blank, suppose I don't know, I want to add something there and I'm not sure what it is. So this will help me just pass and check whether the code is okay for the first one. So assuming this is a more complicated code. So we're going to run it and see what we have. So here we have everything that is divisible by 2, and that is what was printed. So anything else was not, because we said pass. So that means nothing else will be printed. So pass will enable us to forget about something for a while. In this case, you don't even need to use a pass, because you can just do that way. You use a pass when you want to save some condition here first to do something later with it, so that you don't forget or something. So by leaving it this way, it means that this will only be executed when a is divisible by 2. So this one will also print the same thing. And you can see the two printouts are equally the same. All right, something else is continue. Continue. So here I can write something here. Print. A is not divisible by 2. So let's see what happens when we do this way. Oops, I forgot F here. Okay, so now we have 0 is running twice. That's strange. So A is 0. The first step is A. Yeah. Okay. Yeah. That's understandable. So we are having 0 is divisible by 2. 0 is not divisible by 2. So this condition is checked, and it's true when A equals 0. And then it also prints this one. Okay. So this actually doesn't help in that way. So we need to do something so that this part is not printed when this occurs. So this will work the same way as writing an else here. So if you write an else and put this one here, sorry, here, now we'll have things running smoothly. 0 is divisible by 2, 1 is not divisible by 2, 2 is divisible by 2, 3 is not divisible. So we have that kind of an order. But we can still use this one. We can still use this one, but get the same result as this one. 0 is divisible by 2, 1 is not divisible by 2. So we just had something here. Continue. That tells Python, if this appends, don't go there, just continue to the next value of A. Okay, so let's see what happens here. Oh, oops. Okay, something. I gotta stop this first. So what should happen, because it's not incrementing anything here? Oh yeah. Okay. So we need something that runs automatically. Something that runs automatically. Because if we say continue, it means you move back here and this has not been executed. So that's going to be very difficult using a while loop. Let me just use a for loop. So I'm going to stop here. I'm going to say for A in range 11. So that will ensure that there's some automation of the increments. Yeah. Now that works. That works perfectly. So 0 is divisible by 2. 1 is not divisible by 2. 2 is divisible by 2. and 0, 3, blah, 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 something like that. So you have noticed that a while loop is very wild. It can run your things forever. So you can run your things forever. So that's very, very wild. When something does not, like in this case here, what we had before, here. So A is 0. And now saying continue here means we are going back to the loop and we are not incrementing. So A will always be 0 and will always be less than 11. So therefore, this loop was going to run forever. This would never stop until you do a keyboard interrupt by pressing Ctrl C. Okay, now what is remaining here is now a break. So we're going to demonstrate here using the same thing. So I'm going to say here, I'm going to remove that. And then here, I'm going to say if A equals 5, break. So that means it breaks the looping, and the looping will not continue after that. Okay, so that means we're going to have the first one. So A is 0. We're going to have 0 is divided by 2. We're going to have 1 is, no, 1 will not be there. 2 is divisible by 2, so it moves to 3. 3 is not, so we don't do anything. 4 is divisible by 2, it moves to 5, and then 5 is equal to 5, and then breaks. So the looping stops there. So it will print from here up to that point, but not including these ones. So first, let's see what it prints without the break. So without the break, we have 0, 2, 4, 6, 8, 10. So we are saying after including this, we are not going to have 6, 8, and 10 because the looping will have broken. And you can see we have 0, 2, and 4. Okay, so let me use GCD to demonstrate. We're going to use a Euclidean algorithm to demonstrate how we can use a break to do some mathematical algorithms. So we have other algorithms that you can use. So this algorithm, we're finding GCD of two numbers A and B. So the first step of the algorithm is to swap if A is less than B. So we do swapping so that A is now B and B is now A. Okay. Now the next thing is now to take A and find the remainder when you divide A by B. Now that B is less, so dividing A by B, the remainder is R naught. Okay. And then that remainder is taken forward, and then you take B, you divide by that remainder, and then you get another remainder. Okay. Now this, so when we had this, that is the first remainder, so we now forget about A, and now this remainder becomes our B, and now this becomes our A. Okay, so we repeat the same step so that we now divide this by this. We get a remainder. Now we forget about this B, And now this remainder becomes our A, and this becomes our B. So again, we divide A by B, we get a remainder. This we forget, and this becomes our A, and this our B. So again, we divide A by B and get a remainder. Then we forget about this. This becomes our A, this becomes our B. So let's check by use of an example. So GCD of a number like 24 and a number like 16. Yeah. Okay. So the first step is, let's start with 16 so that we see how things will work. 24. Okay. So now we know A is 16. B equals to 24. So the first thing is to swap if A is less than B. So A is now 24 and B is 16. Okay. Now we find our remainder. So remainder, divide 24 by 16. So that will give you a remainder of 8. Okay, so now our A becomes the 16 and our B becomes the 8. Okay, and now we again do 16, the remainder, when you divide by 8 equals 0. Now the GCD here, so when it gets to 0, we stop, because the GCD is the previous is the what follows the 0, that is the previous non-zero element. So this B will now be our GCD, because we have found 0. So we stop there and we look back. So the previous B is going to be our GCD. So how can we implement that in our program so that we can find GCD of two numbers, A and B? So let's first do, we can do it as a function, or we can just do a program. So I'm going to do a program where I'm going to ask the user to input enter A and B. Can copy paste this. I'm going to change that to B. Okay. Okay, so the first step is to check if A is greater than B. If A is less than B. And what we do is to swap. Now, see what happens here if I swap. So I say A equals B. So we cannot do this. B equals A. No. That means we are going to have to lose one of the values. Because suppose A is 24, suppose A is 16 and B is 24. So if we say, so suppose A equals to 16, like we discussed there, and B equals to 24. See what happens here is if A is less than B, which is true, then A equals to B. So now A becomes 24. And you say B is A, so A is 24, so B is going to be 24. So we're going to have A is equals to 24, B equals to 24. So we have to create some dummy variable here. We call it swap equals to A. Okay, A equals to B, and then B equals to swap. So this will enable us to store a variable, this value of A, which is 16. Now swap is 16. And now A is 24, and B is the 16, which was stored by swap. So that's an easy way of swapping. Okay, now something else is we need to do something. So we want, so I'm going to say we want R to never be equal to 0. And R will never be less than 0, okay? The remainder will never be less than 0, will always be greater than 0. So we want to do our loop so long as our R is greater than 0. But we need to provide our R here so that we know what we are talking about. To initiate an R so that at least we have somewhere to begin. So for example, we have R equals to A, the remainder of A divided by B. So this gives the remainder, okay? So if you can see here, 5 divided by 3 should give us what? 2, which is the remainder when you divide 5 by 3. So this gives the remainder. Now here we're going to say, I'm going to say if R, no, we don't need to say that. I can say here, while true, and then here the first thing I say, if R equals to 0, I'm going to break. Okay, so that will ensure that when R is 0, we will not do anything. Okay, so we want to do something when R is not equal to 0. And that something we want to do is, again, I'm going to repeat that procedure there, A percentage B. And then I'm going to say, I'm going to change the values of A and B to read the new values. So I'm going to adjust A and B all the time after every iteration. So for example, I'm going to say A equals to, so now A equals to B when we run the code, and B equals to R. So like I explained here, yeah. So our R in the first step here, our R equals to 8. Now our A is going to be B and our B is going to be R. Okay, so this process will be repeated so long as R is not equal to 0. When it's equal to 0, we stop whatever it is we are doing. And then I said that the last B will be our GCD. So let's try and run this and see if it's doing what we want it to do. We're going to try with that 16 and 24. I'm hoping it gives something. So unfortunately, it gives us back 0. I'm going to try and see what the problem is here. So we are saying if r is equal to 0, so something is not happening here. So r equals to that. I'm going to print something here, print, to see what is happening with the code. So I'm going to say a equals a, b equals b. Okay, so let's see what happens. And let's see how many iterations we have. So 16, 24. So let's see. The last b. Okay. So let's, I think the best way is to run this. According to this, you can see something, it's being assigned. So it's not breaking immediately. So like at some point where r is 0, it's going to give b the value of r, which is 0, before it looks at this. So the best way to avoid that is to take this here on top. So that it does the thing, and when it's 0, this b will not be changed. So let's see the difference here. So we're going to use the sum 16, 24. And now you can see we have obtained 8. So here you can see when this was here, it did the final calculation and it was 0. And then r was 0, b, r, a was changed, and b was changed to 0. That's why we were getting the wrong thing. So that is a type of error called what? Semantic error. Semantic error means, semantic actually means the meaning of the program. So semantic error means you're getting what you do not want to get, which is 0, and the GCD is not 0, the GCD is 8. So you need to solve that semantic error by rewriting the code so that you obtain whatever it is that you want to obtain. So so you need to do some practice. There's an algorithm for finding the square root, I think. So I'm going to write you the algorithm here, and then you're going to try and solve, write a program to what? To using the algorithm. So it's called the Newton's method, or Newton's algorithm for computing square root. So I'm going to include the link down on the description area of the video, so you can check it down there. You can read the Newton's algorithm and then try to write a program to find square root using the algorithm. Okay, so thank you. That will be it for now.